tools required for operation are specifically stipulated. The fitter mounts the airbox on the engine. It's the bike's lung, filtering and regulating the intake air for combustion in the cylinders. For the next work step, the lifting column moves upwards. The aluminum swing arm is still naked. The rear wheel is still being prepared for installation in the swing arm. Wedge-shaped torque dampers made of hard rubber are inserted in the hub. They dampen the force created when driving off. The chain sprocket, with its 44 teeth, seals the hub and is pressed in place. The hoist saves the worker's back and guides the 12-kilogram rear wheel into the swing arm in a perfect fit. At 200 kilometers an hour, the wheel will rotate 28 times a second. The drive chain consists of high-grade steel that is super hard, yet at the same time elastic. It is riveted hydraulically. A mass producer like BMW also improves certain components and electronic systems in ongoing series production. So the Double R is constantly undergoing further development. To achieve this, above all, the firm's engineers need data and experience obtained from practice. That is why BMW cooperates with selected race teams, like NRT 48. At the circuit in Uschersleben, an 8-hour race is in progress. NRT 48 is competing in the Stock Sport World Championship with 2 Double Rs. The team has already practiced the pit stop hundreds of times. The wheels are changed, the tank filled, and the bike roars off again. In the Stock Sport class, there is a ruling that is highly important for cooperation with BMW.
We compete with bikes that are virtually production models. We are not allowed to modify the important components, the frame, the arm, the fork, the engine, and the intake silencer. So our bikes have the original harness and original lights. In other words, 90% of the parts are original components. From that perspective, the customer rides the same motorbike we race with.
During the race, the onboard computer records an enormous volume of data, which in the pit is made visible on a laptop. The cryptic diagrams and graphs provide information on the bike's weak spots.
I'm looking at how the front wheel loses speed when it's in the air. Basically, it's just to see whether the brake has operating clearance.
During the season, teams like NRT 48 drive hundreds of thousands of kilometers, always pushing their superbikes to the limit. Their vast experience also influences production at the Berlin motorcycle plant, where software updates or new electronic and engine settings will be implemented.
Developments from the cooperation flow back into the factory. In this way, we ensure that our developments in the motorsport sector are an open source. Every customer, private or professional, can benefit from our experience.
The S1000RR has been on the market since 2009. But it took tremendous efforts before the model could enter series production. The development process lasted several years. It all began in 2005 with a few pencil sketches. What could a new superbike look like? Performance and design have to harmonize. Sporty handling characteristics have to function not only on the circuit, but also in everyday traffic on ordinary roads. From the finished draft, a one-to-one clay model is produced, which serves as a template for all later scans and installations. Then what is known as a FEES model is milled. Weighing several tons, this metal pattern will be a template for most of the components in subsequent series production. At the same time, the engine is mercilessly pushed to its limits on a dynamometer. Vibrations, gear change behavior and temperatures are intensified to limits far beyond what a rider could cope with. These tests provide important data for developers. The Double R reaches maximum performance of 199 horsepower at an engine speed of 14,300 RPM. The prototypes also spend hundreds of hours in a wind tunnel. At wind speeds of up to 300 kilometers an hour, along with aerodynamic properties, the temperature distribution on the machine is also optimized. Engine, transmission, and exhaust reach a temperature over 100 degrees. These parts can only be cooled by the headwind. Paraffin trails make the flow lines visible. The engineers test various fairings until they find the optimum balance between aerodynamics and cooling. On the test circuit, experienced test riders then analyze the handling characteristics of the new Double R. It is here that electronic assistance systems like ABS and traction control are brought to series production readiness.
I'm trying to tune the traction control so that a rider who is not so experienced will be able to handle the enormous engine performance. So that when he opens the throttle coming out of a turn and the rear starts to drift slightly, he doesn't take a tumble.
The prototype is then subjected to long-distance tests on the circuit. When they have determined the basic configuration of the Double R, the developers test camouflaged prototypes on public roads worldwide. In their design and performance, these bikes are the same as the future production models. The special paintwork makes it hard to distinguish the shape of the bike. On no account must the press catch wind of the new model and publish photographs prior to its market launch. Secrecy is still paramount. Over 60 test drivers put the bikes through their paces on all 5 continents and in all the world's climate zones. Since the superbike is to be sold worldwide, it must function perfectly in all weathers and in all road conditions. In the end, the prototypes will have been driven more than 1 million test kilometers. 4 years after the first pencil stroke, the Double R is officially launched. Up to 1,800 new motorbikes are registered each year in Germany alone. Basic cost, 18,000 euros. The oldest tract at the motorcycle plant houses mechanical production, a department of great importance. This is where the most complex engine components are customized for assembly.
Each day, around 4,300 parts leave here for engine assembly. This is where we manufacture the main components: cylinder head, crankcase, on rods, and crankshaft.
This places the highest demands